Okay, welcome everyone. So in this session, we have Sarah Johnson, Community Engagement Manager at Coiled, and she'll be presenting Scaling Data Science in Python with Flask. Dask, excuse me, sorry.
No worries.
Just a quick note that please post your questions in the Q&A box instead of the chat. And Sarah, a reminder to start your timer. And off to you.
Great. Thank you so much, Rebecca, for that intro. So I have just opened up a poll, and this is just to see, like, in the audience, who has some experience with Dask. So you can go ahead and fill that out, and then we'll return back to it in a little bit. So today I'm going to talk to you a little bit about Dask, and I put this in the chat, but all the materials and setup are available in this repo. My plan for today was to be able to have you all use something called Binder, which would have let you interactively start up all of these notebooks just in a browser. But unfortunately, Binder is not cooperating very well this morning. It was working great last night. It is a free service, so that's the way it goes sometimes. So that's all right. We'll just plow on ahead. But what you're going to do is you're going to go to this link here that was in the chat, and you are going to navigate to the notebooks directory in there. And that's where you will find this first notebook and then the other two notebooks that I'm going to be stepping through today. So to get started, I'm going to frame a common problem that you all as data scientists and data practitioners have surely come across before. So let's say that we have a data set. It's a time series and we have one row per second. And this data set that I'm referring to is actually publicly accessible via this link. So in pandas, let's say we wanted to take 1 week's worth of this data set and perform some calculation. Let's say we want to look at the counts of unique values for a given column. So we would import pandas, we would read in the data, it happens to be stored as a Parquet file, and we could look at the number of unique values across each different name in this column. And that's pretty straightforward. But what if you wanted to look at more than a week? Like, let's say for the full data set, we have 20 years worth of data. The compressed size, so on disk, it's over 16 gigs, and uncompressed, it's nearly 60 gigs, which 60 is far too big to fit in memory on my laptop anyway. So one solution that we might have to this problem is to read and process this data set into chunks. So what we might do is we might loop over each of the files, only reading in some of the data at a time. And we might sort of aggregate this calculation as we go, so summing together the number of the unique values in this name column, and then we would do some reduction, so like aggregating all of those counts at the end. And what we would get is a result that is much smaller than our original 20-year data set. But each of these operations, so the reading in the Parquet file and calculating the number of unique values, doesn't actually need to happen serially in a for loop. We could read the chunks and calculate the number of unique values in parallel, and then do our sum at the very end. The tricky part can be figuring out exactly how to break a computation into chunks. In this example, it is intentionally fairly straightforward, but there are other computations that can become a lot more complicated, and that's where Dask can be very helpful. Okay, so what is Dask? Dask is an open source parallel and distributed computing framework for Python. It supports larger than memory computation, enabling data processing and modeling for data sets that don't fit into RAM. It's used in a wide range of domains, from finance to retail, academia, and life sciences, and there's actually This video or this blog post, they're both really nice overviews on the different users who use Dask. And it's also leveraged internally by a number of tools that you're probably familiar with. So XGBoost utilizes Dask, Rapids, PyTorch, Prefect, and Airflow. It's also developed in ongoing collaboration with the PyData community. So that makes it easy for you as Python users to learn, integrate, and operate it. So the familiarity of the different Dask collections like Dask Data Frame to Pandas can allow you to quickly get started on whatever hardware you would like to. So we can use Dask on a laptop, cloud service, or an HPC cluster. To give you a little bit of a sense of what it looks like to use Dask, so if you're familiar with NumPy, Pandas, or even scikit-learn, you can think of Dask as sort of a faster cousin. So below we have this example for comparing the syntax for a group by using Pandas on the left versus the Dask data frame collection on the right. So here we're importing Pandas, reading in a CSV file, and doing a group by and then a mean. The Dask data frame syntax, you'll notice, looks very similar. You'll see a slight difference in this read CSV line. So here we're actually passing in a glob string. So we're reading in a bunch of different files here. And then this compute we'll talk about in the next steps here. So, but this means that we're now pulling this into memory. So here we weren't actually reading anything into memory at all. And we'll talk about that in a little bit. So how does Dask work? We can think of Dask at a high and a low level. The high level collections are these first three rectangles. So we've got Dask Array, Dask Data Frame, and Dask Bag. And they respectively mimic NumPy, Pandas, and lists, but they can operate in parallel on data sets that otherwise wouldn't fit in memory. Dask delayed and futures, so these bottom rectangles, those are low-level collections for more custom computations. And what these collections do is within each of them, they create this task graph, and that task graph is then executed by one of the different schedulers available in Dask. So these dynamic schedulers can execute the task graphs from either of these high-level collections or the custom workloads. And in our workshop today, we're going to be focusing mostly on the Dask data frame collection, but we'll touch on some of the other collections as well. So when should you use Dask? If your data fit very comfortably in memory and your computations are already very fast, then Dask probably isn't going to be the right tool. You're going to see the biggest performance improvements for problems that are memory bound or compute bound, or perhaps both. And if you don't have either of those problems, then you're probably better off using Pandas or scikit-learn directly. If you're still not sure, I've linked a nice post here in the Dask docs about when Dask can be the most helpful. And then here is just a diagram showing on the x-axis, we have the size of the data. And on the y-axis, we have your model size. And for if your computations fit in this lower left-hand corner, if this describes your workflow, then you probably don't need to use Dask. But everywhere else is fair game. Dask will probably be able to help you. So in the next about 40 minutes or so, we're going to load and process some Seattle bicycle counter data, and we're going to rely on the Dask delayed bag and data frame collections. We probably won't have time to get to this today, but I also included an example of how we can forecast those counts using the profit package and how Dask can help us. And then we're also going to get to monitor all these computations using the interactive dashboard, and we'll have time for Q&A at the end, but then I'm also going to ask people for questions as we go. So on that note, do we have any questions in the chat at the moment?
I don't see any. I think we're good.
All right, we'll just keep on rolling then. Okay, so now we are on to the fun part. Um, all right, so this, just as an initial warning, this example is going to go through sort of a worked example of how I might actually use Dask to ingest data, do some data processing, and then run a simple model. So it's intended to kind of show you what a workflow could look like and how Dask could help you speed up that workflow. That being said, there's a lot of information here, and it's entirely possible that you may not understand every step, because this is going to go by quite quickly. We don't have very much time to go through this workshop. So I just want to iterate here and emphasize the fact that all of these materials are available on the repo, so you can download this information, and it's for you, so you can go back and try things out, and have it make more sense to you as you go along. And I've included links and resources as you go at every step, so you can dive deeper into some of the internals as you would like. So just sort of that initial caveat to start. So in this first cell, we just have all of our imports, and I also have a token that we'll get back to a little bit later. And then we're going to start by creating a cluster locally using the resources available just on your computer. So when you later, after I'm done talking, you can go and download, you can clone the repo and create this environment, and then run all these cells just on your own computer. And I just want to highlight here this syntax. So we're starting a cluster, and we've called it, we're using this local cluster class, but Dask works on your own computer. It also works in a cloud environment or on an HPC cluster in a lot of different scenarios. So this will change depending on whichever environment you're using Dask in. And then we can take a look at the client here, and we'll notice we have a link to the dashboard, which we'll go into a little bit later. We can click through these, they're called widgets, so the IPython widgets here, and we can actually see what Dask has created. So we can see we have this local cluster, it's running on my laptop, we've got a scheduler, and we've got some workers here. You can see the number of threads, memory, etc. And to kind of go over like what all of these words mean. So so the scheduler here, that's this like purple block, that's the task manager, and it takes the task graph and sends those tasks to the workers for execution. The client in green here is the user-facing entry point for cluster users. So that's why up here, like this lives on my own Python session, and I can interact with this client and get information from it. So yeah, as I said, the client lives where your Python code lives, and it communicates with the scheduler to pass along the tasks to be executed. The workers, they do the actual computation, and they communicate back to the scheduler if and when they're successful. So for a deeper dive on all of this, I highly recommend the journey of a task, and that's in the Dask docs. So the data set that we're going to be using today is from Seattle's Open Data Portal, and we're going to use bicycle counter data. I like to bike in Seattle, so I thought that would be kind of an interesting use case. I pre-selected a couple locations that are known to have slightly more reliable counts. Sometimes the counters go down. And those 3 locations are going to be the Fremont Bridge, a downtown location, so it's 2nd Ave, just south of Madison Street, and then the South Spokane Street Bridge. So we're going to use the Socrata Open Data API to pull this data. And if you're not familiar with using an API or with with REST APIs, you can see these Socrata docs for a little bit more information on that. But the important thing to know is that if you're not using Dask, the usual way you might do this is using some sort of get function. So that's what I have here. And you'll use that get function and sort of iterate over pages of results. So this dataset dict is just a dictionary where I've hard-coded the unique identifier for the downtown location for the bicycle counter data. I'm going to use the token that I mentioned earlier, and that is, if you're not familiar with tokens, you can think of it as a sort of password that authenticates that I'm the person pulling this data. You don't need that to get started, but if you don't have a token, then the API will limit the number of results you're able to pull. So here we're just reading in our results using this get function for the downtown bike counter, and we're going to set a limit to just the first 2,000 results. And then because 2,000 is a big number to print on a screen, we're going to make that even smaller and just look at the first 5 from that list. So here you can see the data that is returned is a list of dictionaries, and that can be a common data format that's returned from a REST API like this. And we've got the date, so each row is going to be the hourly data. We've got the total cyclists that were counted, and then we've got that split out by northbound and southbound. And we have this for, as I said, the first 5 rows of our data. So that's all without Dask. But with Dask, we are going to first reach out for the delayed collection to parallelize what would otherwise be a sequential for loop. And for more practice on Dask delayed, you should definitely check out this tutorial and this screencast. But for now, I'm just going to show you the syntax briefly. So you're going to see that here on the left-hand side, we have the direct comparison without Dask. So the syntax changes just slightly using Dask delayed. We're going to pass in this get function to Dask delayed. And then we'll have the rest of our arguments here afterwards. And then we're also going to define a couple functions that will help us loop over the results for every row in this downtown bicycle counter data set. So this first function you don't really need to worry about. It's just grabbing the total number of rows in the data set. And this second get results function, what it's going to do is it'll loop over chunks of pages, and it'll the meat of this function is here. So we're going to add a Dask delayed to our list of results as we go. And then we're going to return that at the end. So what that looks like now when we actually use this get results function, and if we look at these results, now we have a list of delays. So before, when we used our get function, we had data in memory. We had this list of dictionaries. But now that we're using delayed, we don't have data in memory because we haven't asked Dask to retrieve it yet. We just have these instructions that say, okay, you're going to use a get function, and then we have this hash afterwards, which you don't really need to worry about. It's just telling Dask that these are all separate functions from each other. We can look at the task graph for this as well using visualize, which is very helpful. And we can see visually these task graphs. So it's this get function, and there's only one element currently in the task graph, but as you add more complexity, then these task graphs will build on each other. And just for a little bit of added reassurance, so if we look at this list of delays and we grab the first one, and then just select the first 5 rows from there, we can use .compute to pull that data into memory. So now that we've pulled it into memory, you can see, this looks exactly the same as it did before. So this is the same list of dictionaries that we saw earlier for our data set. So what Dask delayed helped us do here is to parallelize our get function. Our data is still a list of dictionaries though, which is really not ideal for data manipulation. So we're going to use Dask bag as sort of an intermediary conversion step. Dask bag is super helpful for pre-processing text and JSON data. And for more on how to use it and what exactly is happening behind the scenes, you can look at this tutorial, or there's another short screencast that is excellent. So here I've commented this out because this is just a reminder of the import. We actually imported it at the top, but the convention is to import dask.bag as DB. And then we're going to use the from delayed function within Dask bag. One important thing to kind of think about as we switch from one Dask collection to the next is that you'll always need some sort of function that will allow you to move from one collection to another. So because we started with a list of delayeds, and now we're converting them to bags, we'll need some sort of function that does that for us. So here in Dask bag, that's called from delayed. And we can take a look at this task graph, and you can see that this get that we saw earlier, now another set of instructions has been added to that called bag from delayed, which makes sense because that's what we did. And we can take a look at the first three elements of this. Again, we have our dictionaries here. And now that this is in the Dask bag collection, we can convert it to what we really want, which is a Dask data frame. So a Dask data frame is made up of pandas data frames. It's partitioned along their index, where each partition is a pandas data frame. And these pandas objects, they can live on disk or on other machines, and Dask data frame implements much of the pandas API, which are backed by these blocked algorithms and allow for parallel and out-of-core computation. For many purposes, Dask data frames can serve in as just a drop-in replacement for Panda frames, but you can check out the complete Dask data frame API, and the Dask data frame tutorial is great for getting a little more practice with Dask data frame. So we're going to use the toDataFrame function to convert this Dask bag to a data frame. And first, we have this is a Dask data frame, so it hasn't been loaded into memory yet. And then when we call .head, that triggers a compute for Dask. So now the first 5 rows have been brought into memory. So now we're gonna put this all together. And while we do that, we're gonna watch what happens on the dashboard. So the 2 tabs that I'm gonna open are the task stream, and I'm just gonna move them so that we can see them here in addition to what we're doing. And then we're also going to grab the progress tab, and we'll set these off to the side, and then we'll close that back. Maybe not. All right, so let's see if we can make this all fit a little bit better. All right, so I'm gonna walk through what is happening in this cell, but essentially it's just putting together all the steps that we just went over above. So here I've hard-coded the unique identifiers for the 3 different data sets we're gonna use, the downtown, Fremont, and Spokane Street locations. We're gonna use that get results function that we defined earlier. And I've set the chunk size to 7,000, and that is something that I decided by as kind of an iterative process between like trying different chunk sizes and seeing what worked the best. And I did that actually using the Dask dashboard. So I encourage you to mess around with it a little bit and see how the dashboard changes. Then we're going to use this Dask data frame method concat, which looks very much like the pandas concat. And we're going to do like a little bit of pre-processing to each of these 3 data sets, and then we're going to concat them all together. So you'll notice we have our from delayed to data frame And then from there, we can work with it as we would a pandas data frame. You'll notice this syntax is pretty much the same. Rename some columns, and then after all of these are concatenated together, we're going to drop the columns that we no longer need. We're not going to look at north or south separately. And then we're going to add in some additional columns. So we'll create this DS column as a datetime object. This Y column will be a numeric from total, and we are okay if some of those values are null. And we're going to create a day of the week and then an is weekend column. And this is all just to show you that the syntax is very similar to pandas. So you can work with a Dask data frame more or less the same way you would with pandas. So I'm going to run this cell, and as I do so, I encourage you to keep your eyes on what's happening on these tabs off to the right. So you'll notice the only thing that's happened is these like 3 long green bars, and they all say bag from delayed. And so that is just these 3 steps here happening at the very top, but nothing else has actually been computed yet. These are all just instructions. There's nothing actually there, but we can trigger some computation. Let's say we would like to know what the average number of cyclists per hour is on the weekends versus the weekdays. So we can run this cell. And that's where we're going to see a lot of the computation. And up here in the task stream, you can see all of the tasks that were set up there. And then down here, you can look at the location and then whether or not it was a weekend and the average number of cyclists per hour for each of those. And then the thing I want to highlight here, so I linked it in the notebook already, but these colors, what they correspond to, you can find this in the docs, but I'm just going to zoom in here. So most of these colors just correspond to the names of different functions. So you can see our concat, to data frame, get item, etc. And that's all great. Other colors apply specifically, so gray is going to be for deserializing, and that's passing messages from your client to your scheduler. And then red is not great, so that's like transferring data. So if you have a lot of red, that's not a great sign. And the other thing you look for in the dashboard is an excess of white or black. So we don't have any black, that means no errors. And it looks like maybe we could get some efficiency improvements over here. There's a little bit of white. And I'm going to show you one trick that might help you make things a little bit more efficient. So if you wanted to ask the question, which days of the week have the highest and lowest average cyclists per hour, we're actually going to use a trick. Let me grab a sip of water. So in order to improve performance, we're going to share an intermediate operation across 2 Dask compute calls. So for most operations, Dask data frame hashes the arguments, which allows duplicate operations to be shared, and then they only have to be computed once. This is because the task graphs for both results are actually merged when calling dask.compute. So we're going to first just grab what I've called the daily average lazy. And what this is doing is it's grabbing the rows where our y variable is not null. So where it's not missing, we're going to group by the day of the week. And then we're going to take the average. So we're going to take that lazy result and we're going to call IDX max. So we're going to get the max and the min, and we're just going to take advantage of sharing these operations across both of those computations. And we're going to call dask.compute on both of those and get the high and the low. So now when we look at this task graph, we can see a lot of these same operations occurring again. And I'm going to highly encourage you to use Dask.visualize to look at the resulting task graph, and then you can see which operations are shared across and which are not. So let's see, at this point, I'm going to pause again and see if there are any questions I can answer for folks or parts of the examples that would be helpful to go over again.
Yeah, I think the only question so far can wait until the end.
Okay.
But lots of enthusiasm in the chat.
Excellent. Glad to hear it. All right. So we can scroll down a little bit. So in the next couple cells, I have an example for doing a simple time series forecast with the profit package from Facebook. And this is actually adapted from an example on time series forecasting that is in the Dask docs. So we don't quite have enough time to go through this cell by cell, but what I wanted to highlight are a couple things. So here, I've just pre-selected just the Fremont Bridge data, and then I'm just plotting the counts versus the versus the date. So on the x-axis we have time, y-axis we have counts, and I just think this is kind of interesting to look at. It's sort of the problem that lots of people who do forecasting have come up against with the pandemic, or challenge to be overcome. But it kind of looked like things were going up, and then the pandemic happened, and that's going to make any forecast challenging. So that's the substantive editorializing I have on that. But these cells, Dask isn't being used at all. So it's just a matplotlib. You can just fit a generic model. This is just picking one out of the box with profit. But the part that oh, right, and then you can use that to make your forecast. You can see here, this maybe not the best of forecasts, but the part I actually wanted to highlight here is profit has this diagnostics cross-validation aspect of it, and internally the parallel backend that it's using is Dask. So you can take advantage of this local cluster that we have already, and it'll make these 14 different forecasts you spread out across the workers that you have available, instead of running each forecast sequentially. So for model building and especially cross-validation, Dask can help speed up some of that. And there's that similar parallel backend for other packages that I mentioned, like scikit-learn and XGBoost and all of those. So that's just what I wanted to highlight there. All right, so I'm gonna X out some of those. So kind of to summarize, so I know that was a lot of information and it was very high level. We didn't really go in depth on any one thing. But hopefully what you've taken away from this is that Dask is it's a flexible open source Python framework for parallel and distributed computing. It's great for larger than memory computations. It uses familiar APIs from other projects you're already familiar with, so NumPy, Pandas. It has some really nice built-in diagnostic tools. That's actually the first thing that I noticed that grabbed my attention for Dask, is where I worked before, we were using Dask for launching a bunch of jobs on our HPC cluster. And in order to track performance and how things were doing, we relied heavily on those built-in dashboards, which was really great. It integrates natively with Python, which really helps benefit from the guidance and influence of the larger developer community. It'll work on your laptop, but it scales to many machines. And you can check out the docs for all the different options. It supports complex applications that are beyond embarrassingly parallel, and if you're familiar, beyond even the map shuffle reduce sort of style computations. And it also has an active welcoming community. So it's a great open source group to join, and the Dask discourse is really helpful and very welcoming. I'm going to highlight just one big caveat here is don't use Dask if you don't need to. So distributed computing can bring a lot of additional complexity into the mix, and there's going to be some cost overhead. So if your data set fits into memory, your computations are not very slow, then that overhead can be larger than the potential performance gain. I've got some next steps that you should definitely go through. So in this order, I would say go back through the Dask interactive Dask tutorial and kind of take that will take you in a deep dive on each of the different Dask collections that I mentioned. The examples and the best practices are also really helpful. And then definitely ask questions on the Dask discourse. I've collected a few like frequently asked questions and answers, mostly from the Dask discourse. And I don't think that you will have these questions right now, but they're here for you to refer back to in your Dask journey. And so the last thing I want to talk about, and part of the reason that I was really excited to present on Dask during the Women in Data Science conference, is because I would love for to encourage folks to join the open source development community, or even join the Dask discourse community. So if you're interested in getting started with open source development, you can check out these guidelines. There's also a really great video tutorial from one of my coworkers who made it for Women Who Code, and it goes over how to get started in open source. And even if you're not interested in development, you're like, I'm a data scientist, I want to play with data, that's great. We would love to see what you're working on using Dask, and you can share that on the Dask discourse. And I will say, so taking my Dask hat off for a second, Coiled, where I work, is hiring. We're hiring for a number of different positions right now. And Coiled is a sort of Dask as a service for using Dask clusters in the cloud. So if you have any questions on any of those positions, feel free to reach out to me directly on LinkedIn, or if you just have other Dask questions that you'd like to ask. Great. So I think that concludes the main portion of this talk, and I want to make sure we have a little bit of time for questions and answering, and any discussion that people want to get into.
Yeah, excellent. Thank you so much for your talk, Sarah. I feel like we all learned a lot. So let's transition over to the Q&A. People can answer or ask questions. You see, like next to the chat at the top on the right-hand side, there's also a Q&A section. We can start going through some of those now. So we have a question from Madison. She asked, one of the biggest barriers I've had to using Dask is the work necessary to set up a cluster, particularly if it needs to be in a cloud. Do you have any advice in this area or suggestions?
Yeah, Madison, so that is a question, as someone who has moderated the Dask discourse quite a bit, a lot of the questions we get are around the challenges of setting up Dask clusters. So I really feel you on that question. I will say the tricky thing on the development side can be testing out everyone's different use cases. So it's hard to give you like general advice, but I will say first, the Dask docs have recently updated for adding more explicit documentation around the different cluster setups and how to get started there. And there are also now a lot of specific questions on the Dask discourse. So there's a high likelihood that you will actually have a similar question that has already been answered there. And then to do a small plug, that is actually part of the problem that Coiled is hoping to solve. So the company that I work for, was part of the impetus in creating that product. So Coiled makes it very easy. You can try it for free. If you have questions on that, feel free to reach out to me afterwards. Yeah.
Awesome. All right. We have another question from Sue. She asked, sounds like Dask is good for larger than memory computation. Are there any other tools for this type of problem? And how about cloud solutions?
Yeah, that's a really good question. So let's see. For that question, I'm actually going to grab a link and stick it in the chat. So the most common comparison that Dask gets is comparing Dask to Spark. So Spark is, I would say, a very popular option for, for doing sort of similar out-of-memory computation. I haven't used Spark at all, to be completely honest. So I am not an expert in telling you like why Dask could be better for Spark or why Spark could be better than Dask. So I've linked kind of a nice blog post here that I think is a fairly balanced discussion, but given it is hosted by Coiled, which we like Dask, so I'll just add that as a caveat. But that's a very common other framework to use instead of Dask. And if you're not using Python, then it'll depend on what language you use. But if you're using Python, a lot of folks really love how easy the syntax is and how low the barrier to entry is to go from Python to start using Dask as compared to Python to start using Scala or using Spark. So, and then I think, was there a second part to that question about cloud computing as well? I think,
Yeah,
oh,
just
there it
asking
is.
about cloud solutions.
Cool. Yeah, and then again, I would say here, I can find the exact link for it. Just give me 1 second. Here it is. So here are the Dask docs. And that should tell you all about how you can deploy Dask on the cloud, which is, definitely a great way to use Dask and a great way to take advantage of those cloud resources if you have them available to you.
Nice. All right. Got another question for you. So you were showing task stream and like the progress windows and things when running a project.
Yeah.
Like, how do you use that when you're running a project? Are there like warning signs that you look out for? Like, what do those look like? And then how do you like change course so you don't not break anything?
Yeah. That's a great question. And I actually, so if we, let's see, if we go back to, there was this example, and then up here, I had a nice link to the, to our, I think it's down here, dashboard. Okay, and then I think, am I sharing now the Dask docs page instead of my notebook? Yes, okay. So on this page, there's actually a really nice overview. So this is what I showed, but there are two main things that I look at. So I didn't show you this because there wasn't a ton of memory being used, but if you notice like a lot of orange in your memory profiler or like a bunch of gray, then that can mean that it means that memory is being spilled to disk or memory is being close to spilling to disk. So it might mean you need to think about reworking your setup a little bit. And then here, This is the main one that I use. So, and this is actually as I was coming up with this example. So I rely pretty heavily on the task stream, and the red refers to transferring data between worker tasks. Orange is reading or writing from disk. Gray is for serializing or deserializing. And black is when you have something has thrown an error. So this task graph looks pretty good, or task stream, sorry. And this one, by comparison, looks very bad. So there's a lot of white space that is not being used at all. And when I was creating the example that I shared with you in my task stream, I actually noticed like a very large orange chunk that looked exactly like this. And it's because I had the syntax written a little bit incorrectly for using delayed. So I wasn't actually looking at, I wasn't actually parallelizing the way that I thought I was. And that enabled me to see it real quick and go, oops, something's wrong. And then I found my mistake and was able to fix it. But yeah, those are kind of the main things that we look at here. Yeah, does that help answer your question?
It does. Thank you.
Yeah,
Thanks
and
for
I
the.
can actually here. I'll share the link to this too in the chat.
Oh, thanks.
Yeah, definitely.
Excellent. I guess I didn't see any other questions in the Q&A. One more that I have, I'm just going to keep asking questions. One more that I have is if you're starting to get used to Dask, if you're just starting out, like how long do you think it really takes before someone becomes comfortable with like all the syntax and actually starting to run your own projects?
Yeah, that's a really good question. And I feel like I sort of like relatively recently went through that kind of on-ramp, and I would say getting familiar with the syntax of Dask, that was pretty quick. So like within a week, I was like, okay, this is pretty much the same as Pandas. Great. Okay, for delayed, it's a little different. Okay, but not so much. And then I would say probably within 2 or 3 weeks is when I was really able to work through like thinking about how I would convert an existing data science pipeline into Dask. So it was like, the first time I thought about it, it was a little clunky because I was like, okay, you're doing two things. You're changing from a non-parallelized or non-distributed workflow into a distributed workflow. So that is one learning curve that is a little tricky. And then you're also converting into thinking about how Dask thinks about those things. So I would say learning them simultaneously, it can be sometimes helpful to split out like what is Dask and what is just parallel computing. And maybe for me, it was identifying which pieces of parallel computing were still kind of tricky and a little difficult to understand. But yeah, I'd say within a few weeks, I was able to sort of work through transferring and converting a data science pipeline into Dask. So yeah, and even there are like little tools within Dask that, as I said, like you could have your whole data frame as a pandas data frame if your data isn't that big, but then use the Dask parallel backend to run all your models in parallel if you didn't feel like waiting around for them, like things like that. Like that's super easy to get started. So it kind of depends on exactly like how much Dask you want to inject versus transforming your whole data science pipeline. That might take a little longer. And then scaling out to the cloud, that would be like an extra little bit. But yeah, I think for me, it seems like Dask makes a lot of those steps a lot easier, especially if you're already a Python user. Yeah.
Yeah, no, thanks. That context always helps. And I guess like for those who are interested in getting into like the open source community and starting to develop, like I don't know, what should they expect? What tips?
Yeah. Yeah, I think like one tip that you hear a lot is that like starting with documentation can be a great place to start. I think with Dask it can be a little tricky because a lot of the documentation it might require some knowledge of parallel or distributed computing, but you can always start with like even like a doc string for a function that you read it and you tried it and you were like, oh shoot, this is out of date, or this argument exists now and before it didn't. Like, that's a great way to just get started. And the developers like really appreciate it because it's open source. So yeah, everyone is like giving their time and their energy to that. And once you sort of get to know people, there are developers who kind of have different specialties, and you'll kind of get to know the faces and the names. And Dask especially is an incredibly welcoming community. People are really excited about Dask, and they really delight in explaining it, is what I found, which is really nice. So yeah, people who love thinking about Dask Array will spend lots of time explaining it to you. And that can help you get started on then looking at the high level, so implementing like a new feature. So not all of Dask has been, or sorry, I should say, like not all of Pandas has been implemented in Dask yet. So there are some Pandas functions that a Dask equivalent does not yet exist. And that's a great other way to get started. So once you get comfortable, you can write like a high level function for some of the Pandas functions that exist that aren't yet in Dask. And that's kind of the next step that I would recommend. But yeah, definitely, yeah, check out the developer guidelines that I linked, and then the video from the Women Who Code session too. There's some other great tips. Yeah, I'd love to see more people jumping in to that. And as I said too, like if you want to just share, I shouldn't say just, it would be also incredibly valuable to share the examples that you're using Dask. So I think there can be maybe, I don't know, for me, I might think like, oh, my project isn't cool enough. Maybe I don't want to share it on the internet, but it's really helpful to see examples of how other people use something to get me started, at least. That's how I start. So I would encourage you all, if you have examples of using Dask, to share them on the Dask discourse as well.
Excellent. Yeah, thank you. And I think just seeing your examples, this was great. Everything was really clear, and it looks like a lot of people learned a lot in this session. So thank you so much. So I think it looks like that is the rest of the questions. So thank you again. Thanks, Sarah. This concludes our session.
Thank you, everyone.
If you have any questions for Sarah, you can reach out direct message in Excel events, or you can connect with her on LinkedIn or send her an email, and I will link all of those in the chat. Yes, all right. LinkedIn is on there. Your email is there. Yeah, so everyone head out to other sessions, expo booths, and thank you all for coming.
Thanks, everyone. Thanks, Rebecca.
Thanks.